Okay, so now what we're going to look at is examples where we're going to take the derivative of exponential functions. So first of all, remember that an exponential function is a function in the form of f of x is equal to b to the x. Now specifically what we're going to be looking at in lesson 1 is our base is going to be e. So remember e is an irrational number 2.71, so it's a growth function. Um, and we're going to take the derivative of e to the x. Now, if I ask you to differentiate e to the x with respect to x, remember that the derivative of e to the x is e to the x. And then what we need to do is we need to differentiate x. So then the derivative of x is 1. So the derivative of e to the x is e to the x. The derivative of an exponential function is itself. So let's look at this first example. I'm just going to rewrite this as y is equal to e, and this will be x to the power of 1/2. Y prime is equal to, so the derivative of e to the x is e to the x. And then I need to multiply that by the derivative of, this is essentially my u. So the derivative of x to the 1/2 is 1/2 x to the negative 1/2. Rewriting this, y prime is equal to, so e to the power of x to the 1/2 is e to the square root of x. 2's in my denominator. I'm going to bring my x down to make it a positive exponent, so that would be x to the 1/2. And then I will rewrite that to give me square root of x in the denominator. So e to the power of square root of x over 2 square root of x. And that would be the derivative. Okay, differentiate x to the 4 times e to the x. So this is going to be a product law question. So here's u, and that would be v. Y prime, remember, is u v prime plus v u prime. So y prime is equal to u and then v prime. So the derivative of e to the x is e to the x, and then I take the derivative of x, which is simply 1. So u v prime plus v, and then u prime. The derivative of x to the 4 is 4x to the 3. What I could do is I could rewrite this as x to the 4 e to the x plus 4x cubed e to the x. And then I could factor from here. So each term has an e to the x, so I'm going to factor out an e to the x. And I've got an x to the 4 and an x to the 3. You could always factor out the lowest power of x. So I'm going to factor out x to the 3 e to the x. And if I do that, my remaining factor would be x plus 1. So that would be my derivative. X plus 4, sorry. X plus 4. Okay, differentiate y is equal to tan e to the x. So first of all, my argument is e to the x. And let's quickly review how we differentiate tan. So if I ask you to differentiate with respect to x, tan of u, the derivative of tan is secant squared u. And then remember, we take the derivative of the inner function, which would be the argument. So then we're going to multiply that by du dx. So just really quickly, to review trig again, if I said, okay, I want you to differentiate tan of 5x with respect to x, the derivative of tan is secant squared u. So it would be secant squared of 5x. And then we differentiate the inner function, which is my argument. The derivative of 5x is going to be 5. And then I could rewrite that as bring the 5 to the front, 5 secant squared of 5x. So this one here, differentiate tan of e to the x. Y prime is equal to. So the derivative of tan is secant squared u. And remember, u is e to the x. So secant squared e to the x. And then I need to differentiate u. So the derivative of e to the x is e to the x. And then from here, the derivative of x is 1. Y prime is equal to, I'm just going to write that e to the x in front, secant squared e to the x. Okay, let's do this one. Now again, this is going to be a product law question. So this will be u, and this will be v. So uv prime plus vu prime. Let's quickly talk about or review the derivative of cotan. So differentiating cotan of u with respect to x, the derivative of cotan is negative cosecant squared u, and then we differentiate the inner function, which would be du dx. Okay, so y prime is equal to u v prime. Okay, so let's think about what v prime is. E to the power of cotan 4x would be e to the power of cotan 4x. So the derivative of e to the x is e to the x, right? And then we need to differentiate. We multiply it by the derivative of cotan. So the derivative of cotan is negative cosecant squared of 4x. And then when I take the derivative of cotan of 4x, the derivative of cotan of 4x is negative cosecant squared of 4x, and then I multiply by the derivative of the argument, which is 4. So this would be u v prime. This represents v prime. uv prime plus v, and then u prime is just 1. And we're taking the derivative. Y prime is equal to. Okay, I'm going to combine x, the negative, and this 4 to give me negative 4x. Then I have e to the cotan of 4x, and then I have cosecant squared of 4x plus e to the cotan of 4x. From here, I could factor out, so there's two separate terms. I could factor out an e cotan 4x. And I would get negative 4x cosecant squared 4x plus 1. The other thing I could have done is from here, I could factor out a negative 1 if I want. So I could pull out a negative 1 in front of, have negative e to the power of cotan of 4x. And then this negative would be gone, and this would turn into a minus 1. So that's sort of another option that we have. Okay, let's look at this example. So again, it's two separate functions being multiplied together, so another product law question. So uv prime plus vu prime. Now differentiating sine of x, the derivative of sine of x is cos of x. And then you'd multiply it by the argument of x, which is, I'd multiply it by 1 here. So the derivative of sine of 3x is going to be cosine of 3x times 3, because the derivative of the argument is 3. So y prime is equal to, so u, and then v prime, derivative of sine of 3x is cosine of 3x. The derivative of the argument is 3. So uv prime plus v and u prime. So derivative of e to the negative 2x is e to the negative 2x, and then I need to differentiate negative 2x. So that would be the derivative of negative 2x is negative 2. I'm just going to bring this 3 to the front, and then I'm going to write e to the negative 2x cosine of 3x. I'm going to bring that negative 2 to the front, and then I'll write the e of negative 2x, and then the sine of 3x. What could I factor? I could factor out an e to the power of negative 2x. And what I would be left with is 3 cosine of 3x minus 2 sine of 3x. Before we do this question, which is going to involve implicit differentiation because we're going to be taking the derivative of y, let's do this one, which is finding the second derivative. Okay, so the first derivative, the derivative of 4e to the 2x, or sorry, 4e to the power of x squared is going to be 4e to the x squared. And then I need to multiply that by the derivative of this function, which would be 2x. So y prime is equal to 8x and then e to the power of x squared. Taking the second derivative, so differentiating 8x e to the x squared, is going to be two functions multiplied together. So it's going to be a product law question. So uv prime plus vu prime. So y prime is equal to, so u v prime, derivative of e to the x squared is e to the x squared times the derivative of x squared, which is 2x. So uv prime plus v, and then u prime, derivative of 8x is 8. This is the second derivative. Second derivative is equal to 16. X and x will give you x squared, e to the x squared, plus 8e to the x squared. And then from here, I could clean this up, and I could factor out an 8e to the x squared. And if I factor that out, I will get 2x squared plus e to the x squared. No, 2x squared plus 1. Okay, let's look at this example. So this example here, we are differentiating this, and you should recognize that, hopefully, that this will be an implicit differentiation. And how I know it's going to be an implicit differentiation is because the derivative of e to the 5y is e to the 5y, and then I need to multiply it by the derivative of 5y, which is 5, and then dy dx. Okay? So this is going to be implicit differentiation, and when we do that, remember what we were doing is we were differentiating both sides of our equation with respect to x. So the derivative of x cubed is 3x squared. Now remember, I could write if I really want to, I just took the derivative of x with respect to x, but dx over dx will cancel. So I could just say that the derivative of x cubed is 3x squared, right? Even though I'm doing implicit differentiation, I don't need to write dx over dx is equal to the derivative of e to the 5y is e to the 5y times the derivative of 5y. Derivative of 5y is 5, and then I just took the derivative of y, so I'm going to write y prime. I want to get y prime by itself, so I'm going to divide both sides by e to the 5y times 5. And this will cancel, and I will be left with y prime, so the derivative is equal to 3x squared over 5e to the 5y. And that would be your derivative. What I recommend doing before you watch these examples being solved, which is going to involve quotient law, and this is going to be a product law with chain rule in here. I recommend you doing some of the homework questions. So the homework question that I would recommend you take 10 minutes to do is on page 366, I'd recommend question number 1. Now, number 1, it's just a simplifying question, so it's basically exponent laws for Math 10C. So, for example, if you looked at this first question here, 2 over e to the negative x, if I wanted to simplify this, I could make my exponent positive by reciprocating and bringing that into my numerator to give me 2e to the x, right? E to the x to the power of 4, power to a power, you would multiply. X times 4 is e to the 4x. So you're not taking any derivatives, you're just simply simplifying. So I would do question 1, and then I would do question 4. And the ones that I would do from question 4 is I would do A, C, E, and I. And then G and K will be once you finish the remaining video for those ones. And I'll assign more